Look up at the moon on a clear night. It's big, it's bright, and even a simple telescope can reveal most of its details. And here's the very first video of astronauts walking on the moon's surface. Actually, this is fake. This is the real one, with Neil Armstrong taking his famous giant leap. And this one, where Armstrong and Aldrin are planting the American flag on the lunar soil. Both these videos were shot on the moon. Which leads us to a question that sounds simple, but has a deeply scientific answer. Why can't we just point a really powerful telescope at the moon from Earth and watch astronauts walking around up there? The answer isn't what you'd expect. Most people assume this is a magnification problem. Get a big enough zoom and you'd see everything, right? Wrong. And this is the key misconception. In astronomy, it doesn't matter how much you magnify an image. It's how much detail you can capture and resolve. These are completely different things. Think of it like this. If you take a blurry photo and zoom in, you don't get a clearer photo. You just get a bigger, blurry photo. The sharpness of detail a telescope can capture is called its resolution, and it's governed by the laws of physics themselves. Here's the physics. Light is a wave. When it passes through the circular opening of a telescope, it bends and spreads. This is called diffraction, and it fundamentally limits how sharp your image can ever be. The science is elegant. The bigger your telescope's mirror, the better its resolution. But the moon is 384,000 kilometers away, and its diameter is 3,475 kilometers. Thus, a full moon appears at an angle of 0.5 degrees, or 1,800 arcseconds in the sky. But an astronaut standing on it is just about 1.8 meters tall. And at that distance, an astronaut appears at an angle of roughly 1/1000th of an arcsecond in the sky. And an arcsecond is already just 0.00028 degrees. We're talking impossibly, vanishingly small. To resolve something that tiny, you'd need a telescope mirror roughly 116 meters wide, nearly the length of a football field. The largest telescope mirror on Earth today? About 39 meters, still under construction, the ELT. The Hubble Space Telescope is just 2.4 meters, and James Webb is 6.4 meters. Magnitudes shorter than what's needed on the ground. And then there's the atmosphere. Now you might be thinking, okay, so let's just build that 116-meter telescope on the ground. Problem solved, right? Not quite, because there's another enemy standing between us and the moon, and it's right above our heads: Earth's atmosphere. Every time light from space travels down to your telescope, it passes through kilometers of turbulent, moving air. Different temperatures, different densities, all constantly shifting. This bends and scrambles the light, blurring the image. It's the same reason stars appear to twinkle. This effect, called astronomical seeing, limits even the best ground-based telescopes to a resolution of about 0.05 arcseconds under ideal conditions. We need 0.001 arcseconds. The atmosphere gives us 0.05. That's 50 times too blurry, no matter how big your mirror is. Building a 116-meter telescope on Earth would be a multi-billion-dollar, decades-long engineering feat, and the atmosphere would still render it useless for this specific goal. Here's what's fascinating, though. The Lunar Reconnaissance Orbiter, a NASA spacecraft that orbits the moon at just 50 kilometers above its surface, has photographed the Apollo landing sites. And in those images, you can actually make out the descent stage of the lunar lander, equipment left behind, and even the dark trails left by astronauts' footsteps and rovers in the lunar dust. The trick wasn't a bigger telescope. It was getting closer. So there you have it. The moon feels close. But when you're trying to spot a 1.8-meter human standing 250,000 miles away, the laws of physics have very firm opinions about what you're allowed to see. Next time you look up at the moon, just know that a dozen humans have walked up there. You just can't see them from here. And now you know exactly why. Stay curious, share this video, and subscribe for more.